All right, this is lesson 5.2, and what we're going to look at today is on page 286, and it's all about divisibility rules. So divisibility rules help us because it tells us whether a number is divisible by another number without having to necessarily do long division. So for example, if I have a number 2, or if I have a number, lesson 5.2 called Factors and Divisibility, and today we're going to look at divisibility rules. So we've learned that we can figure out if a number has 2 factors by either drawing models or doing long division, and if there's no remainder, then we know that those numbers are factors of that number. But sometimes we don't want to do long division for every single number in order to figure out if a number is divisible by something. So that's where divisibility rules come in. So these are the divisibility rules up here. So you know that a number is going to be divisible by 2 if the number is even. You know that a number is divisible by 3 if the sum of the digits is divisible by 3. You know that the number is divisible by 5 if the last digit is 0 or 5. You know the number is divisible by 6 if it's even and it's divisible by 3. And then you know a number is divisible by 9 if the sum of the digits is divisible by 9. Now, this isn't every number, like we're missing 7 in here and 4 in here, but for the most part, this is a really good start to help you not have to do as much math. So we would look at, is 6 a factor of 72? So the divisibility rule for 6 is the number is even and divisible by 3. So is 72 even? Yes. And then what is the sum of the digits? The sum of the digits means I have my 7 and my 2. Those are my 2 digits. So 7 plus 2 is 9. All right. So is 9 divisible by 3? Yes. So that means 72 is divisible by 6. So 6 is a factor of 72. Look at try this section here. So we want to complete the table and find all the factors of 72. So we're going to start right down our list. So we're going to look at, does 2 go into 72? Okay, so we have 2. The number is even. So yes, it does. I don't know how many times yet. So I can do 72 divided by 2. So 2 goes into 7 3 times with a remainder of 1. 2 goes into 12 6 times. So 2 times 36 equals 72. So the factors would be 2 and 36. Then I want to know, does 3 go into 72? So if the sum of the digits is divisible by 3, then it is. So 7 plus 2 equals 9. 9 is divisible by 3, which means that 72 is divisible by 3. So I have 3, and now I just need to figure out 72 divided by 3. So 3 goes into 7 2 times with 1 left over. 3 goes into 12 4 times. So 3 times 24 equals 72. So 3 and 24 are factors. And then we don't have a divisibility rule for 4. It is actually that if the last 2 digits are divisible by 4, then the whole number is divisible by 4. But because we only have 2 digits here, it doesn't really help us. So we just need to do 72 divided by 4. So 4 is going to go into 7 1 time with 3 leftovers. And 4 goes into 32 8 times with no leftovers, which means it is divisible. So 4 and 18 equals 72. So 4 and 18 are factors. Now 5, we know, does not go into 72 because the last digit is not 0 or 5. 6, if the number is even and divisible by 3. So we already know that the number is even because it's divisible by 2. And we already know that the number is divisible by 3. So that means 6 is also going to be a factor. All right. So if we do 72 divided by 6, it's 1 with a remainder of 1 and 12. And hopefully that's a basic fact. And then we have 7 is not going to go in because I know that 7 times 10 is 70, so there's no way that another group of 7 is going to get me to 72. And then I have 8, which is a basic fact. 8 times 9 is 72. So we have 8 and 9. And it's also if the sum of the digits is divisible by 9. So if 9 is divisible by 9, then it is 287. So this is asking, is 5 a factor of the number? So the divisibility rules are the last digit is a 0 or a 5. So this is not a 0, so no, 5 would not be a factor. This is a 0, so yes, 5 would be a factor. Down here, we're looking at, is 9 a factor? So that's if the sum of the digits is divisible by 9. So if we have 5 plus 4, that equals 9. 9 is divisible by 9, which means 54 is divisible by 9. And over here, 93, 9 plus 3 is 12. 12 is not divisible by 9, so that means 93 would not be divisible by 9. And then we're going to look at number 11, where we want to find all of the factors of 39. So what we're going to look at first is we know that 1 is going to go into that. So we have 1 times 39 is going to equal 39. So our factors are 1 and 39. Now we know that 2 does not go into it because it's not even. So 3, we're going to check if 3 goes into it. So the sum of the digits, 3 plus 9 is 12. 12 is divisible by 3, which means that the whole number is divisible by 3. So 3 goes into 39. If you didn't know what that was, we could do 39 divided by 3. 3 goes into 9 3 times, so 3 times 13 would be 39. At page 288, number 14 says, Dirk bought a set of stamps. The number of stamps in the set he bought is divisible by 2, 3, 5, 6, and 9. Which set is it? So we need to find out which one of these numbers is divisible by all of those. So first of all, if it's divisible by 2, I know the number needs to be even. So that means I can cross off Japan and I can cross off Canada because both of those numbers are not even. So you can see right away that's very helpful. Now, if I look at it's divisible by 5, that number has to end in a 0 or a 5. So 78 does not end in a 0 or 5, so I can cross out Sweden, which means Germany is the only stamp set that is divisible by 2, 3, 5, 6, and 9. So I didn't have to do any math up there other than knowing the divisibility rules and figuring out which ones to eliminate. Is number 17 on page 288. So we want to know which of these numbers go into which boxes, and they can belong in more than one box. So we want to know if 27 is divisible by 5 and 9. So I know that 27 is not divisible by 5 because it does not end in a 5. 45 is divisible by 5 because it ends in a 5. And I know that 9 times 5 is 45, so 45 is going to belong in this box. Now 54 is not going to be divisible by 5, 72 is not going to be divisible by 5, 81 is not going to be divisible by 5, and 84 is not going to be divisible by 5 because none of those end in a 5 or a 0. So I'm done with this box. Now I want to know if they're divisible by 3 and 9. So in order for it to be divisible by 3, the sum of the digits has to be divisible by 3. And in order for the number to be divisible by 9, the sum of the digits has to be divisible by 9. So we want to add up the sum of these digits for all these numbers. So for 27, 2 plus 7 equals 9, right? So that's how we're doing that. 2 plus 7 equals 9. 4 plus 5 equals 9. 5 plus 4 equals 9. 7 plus 2 equals 9. 8 plus 1 equals 9. And 8 plus 4 equals 12. So for divisible by 3, all of these are divisible by 3 because 3 goes into 9, 3 goes into 9, and 3 goes into 12. But also, they have to be divisible by 9. So 9 is divisible by 9, so that means all of these that add up to 9 are divisible by 9. But this one, 84, is 12, so 12 is not divisible by 9. So 84 would not belong in the box, but the rest of them do. So we have 27, 45, 54, 72, and 81. Now the last one is, are they divisible by 2 and 6? So the first rule for figuring out if they're divisible by 2 is they're even. So we can skip 27, skip 45. Now we can look at 54. So 54 was divisible, or if we add up the sum of the digits for 54, 5 plus 4 is 9. So that means it's divisible by 3 and it's even, so 54 belong in this box. Next we have 72. 7 plus 2 is 9, so that's divisible by 3, and it's even, so 72 would belong in this box. 81 is not even. 84 is, and 8 plus 4 is 12, which is divisible by 3, or it is divisible by 3, and it's even, so that means 84 would belong in this box as well.